Hi, I'm Karthik, and this is Mu, a half built computer that aims to be self sufficient and designed to be taken apart. Mu builds upward from the lowest level of software, machine code. Here's a tiny example program. We have instructions 1 to a line. Each instruction, because this machine code, consists of just numbers in hex. There is also some metadata for error detection. Mu has minimal dependencies, so there's nobody but me to blame if it breaks. It should install painlessly for you on any Unix or Mac machine with a working C compiler. Running it, as you can see, transparently runs the compiler for you. There's an online help system that you can browse. And there's oodles of tests which give you guardrails if you ever need to make changes to Mu. Here's our example program again. All it does is return 42. Let's run it. First, we translate it into a native binary, and then we run it. Bootstrapping can be slow, so you can also run it natively, but this requires Linux. You can package up Mu programs with just a Linux kernel and create a bootable disk image. It takes half an hour, so this part of the demo is pretty sped up. But at the end, you can run Mu programs with just a kernel and nothing else on your computer. And while it's large, a kernel is much smaller than a complete Linux system. There, that's done. And you can now boot up with the disk image. Take my word for it that this worked. Mu has a high-level language. Here's our program in this high-level language. Here's a more complex program. Most instructions translate to a single instruction of machine code, and it will eventually be safer to program in than C. To close, I'll leave you with a series of refinements of this program, gradually expanding it to raw machine code. All these stages of translation were performed self-hosted in Mu itself.